everyone, to Slurky and Sass Go Nuts. Let's see, you can see the slides up above. But thank you so much for being with everyone. We're really delighted that you made it. We are Snarky and Sass, aka Bethany and Marie. But if you've been to any of our previous sessions at VWBPE, you may already know why we're using, the metaphor of the frantic squirrel. Whether you through a rapidly changing forest, try to decide which acorns are worth saving, which are rotting on the ground, which ones are going to bonk you on the head before you even see them coming. Today, we're going to talk about 6 years of virtual reality exploration, over 30 hours of recorded conversations, 32 audio transcripts, a lot of AI assisted analysis, and two models that did not always agree and sometimes made things up entirely. So buckle up because the acorns are a flying. So let's just take a moment to situate who we are and why we're here in front of you with this particular story to tell. We're educators and information professionals at the School of Information, as well as a state university. Librarianship, archives, information ethics, technologies, and teaching, all of that's on world. And we've been Second Life residents for a long time. And no matter where else we go or where we meet, we find ourselves coming back to Second Life again and again. Because after we've been out exploring, 6 years ago, we started the VR Exploders, and the name should tell you everything you need to know about our general disposition towards these platforms. We're not VR evangelists or hype merchants, but we're skeptical explorers. We have a lot of fun, exploring very serious topics. The VR Explorers have been a monthly expedition that started in late 2019 and really only ended last year when we settled on a platform to explore more deeply. Well, but over those 6 years of our life, we've picked a different social VR platform to then visit, and all of our colleagues who explored the environment and captured our insights. We started live streaming our outings to preserve the visuals and the conversations and in the moment insights that were being shared. And we look at social virtual spaces through the lens of educational usefulness. Not is this impressive or feel like the future, but could a real instructor use this environment with real students in a real course? We've been doing this since 2020, and while we've come to focus on one particular social VR platform to work with, aside from working in Second Life, but that's not what we're here to talk about. Today, let's take a meta look at the entire journey, and we're bringing AI into the analysis in ways that got interesting very quickly. Whoops. So before we dive into the data, we want to spend a moment on the bigger picture because the talk is not really just about the VR platforms. It's really about how everyone in this room is navigating in their professional lives right now. All of us as information professionals and educators have an ethical and professional obligation to protect information, preserve its provenance, support access to it, and help people find and discern between what is real and what is not. And right now, that job is getting exponentially more complicated and challenging. Information abundance and disinformation are accelerating simultaneously. The tools that generate content are getting more powerful every month. And the platforms where learning happens are multiplying and fragmenting. And the people we serve, our students, our patrons, our communities, they're also trying to make sense of all this in real time. And is it any wonder that we feel like squirrels in a quickly growing forest where the acorns are falling faster than we can bury them? And, some of them are fake acorns and some of them are acorn-shaped rocks. And every now and then a large one, hits you on the head. Virtual environments and AI are part of all this shift. They're not a separate phenomenon or phenomena. These are increasingly intertwined tools that educators, and professional information professionals have to understand, not just to adopt to their use, but learning how to actually interrogate the output in a way that we can feel confident in our collaborations. We want to give a nod to Ethan Mollick's concept of co-intelligence. Mollick talks about AI as a kind of second brain, a thinking partner that can help you work at a scale you couldn't otherwise reach. I know it's not an oracle or a replacement for human judgment. It's a thinking partner. And it's often described as an excellent graduate student assistant that you have to supervise really closely. And that framing is going to matter a lot here when we get to the AI section of our talk, because it shaped both what we had tried to do and what we learned when things went sideways. And seriously, I can't help but interject that this thinking partner drives us both nuts. Unless you think that Claude wrote that as a joke, I can assure you it's on me, Snarky. Or is it Sass? Or is it an AI bot that I've trained on my writing whose output now sounds enough like me that I confuse even myself? And I'm only half joking and saying that out loud. Somebody please confirm I'm not alone in feeling this way. So let's get back to the beginning. In 2019, we decided we needed a framework. This is late 2019. We couldn't just wander into VR platforms without a plan. We needed criteria. We needed something where we could let us compare across platforms, across time, different kinds of experiences. We surveyed you guys. We surveyed you guys, the you educators in the room. We asked you what matters most if you're going to use social VR for teaching and learning. And, we needed something like a rubric, and they got clear answers. We got 8 of them, actually. The approach that we've been using ever since is observational, conversational, and exploratory. We've previously presented some findings from our surveys that we did after our add-ons, but this presentation is about the data based on the actual conversations we had in World with our colleagues as we were exploring them. In these outings, we were trying to do things educators told us were essential. We talked about what we were seeing, doing, and experiencing in a moment. So our orientation has always been focused on the educational usefulness. And I want to add, too, that this was during a time when there was a lot of hype surrounding VR. You guys remember? Before AI became a thing, everyone was talking about the metaverse and VR. We were never swayed, however, by the feeling that, immersion in the headset that was never enough. We were constantly orienting towards our North Star and asking ourselves, how well could this work for teaching and learning? So the question we're answering today, 6 years and 32 recorded sessions later, is, were we right? Were the things that we identified in 2020 actually the things that mattered? And what did we miss? Kind of the 8 criteria that educators identified in 2020. First is voice, not just whether a platform has it, but whether it's reliable and other ways that, instructors can control it. Can you mute someone who's being disruptive? Can you broadcast to a whole room? Does it hold up when 6 people are talking at once? Second was the support for real-time presentations like this. This means synchronously and visibly to all participants and working across all devices. An instructor shares a slide deck, does everyone see it? Does it update in real time? Does it work for the person on a laptop the same way as for a person in a headset? That is the onboarding experience. And this, we don't just mean, is it easy to make an account, but what's the real learning curve here? What happens for students who've never used VR or that particular platform? How much time does it take away from teaching to do that onboarding? The fourth criterion, of course, was grief or handle, because it is essential to be able to block, eject, and protect participants, especially in open worlds. In the educational context, that's absolutely a prerequisite. The fifth criterion is being able to use videos and multimedia. Can you show a video in world? Can you record the session easily? The sixth is desktop VR access. Headsets should always be optional. If a platform only functions meaningfully with a headset, it's not viable for most educational institutions. Seventh is the ability to teleport. This is more than just a convenience. It's an educational context. It's a regrouping tool for educators. It's how an instructor keeps a class together when you're moving between spaces. We've been in a lot of very large spaces without this feature, and it is ridiculous having to run for 5 minutes to get somewhere. The eighth criteria is a cross-platform collaboration. That means headsets and desktop users, they need to be able to be in the same space, participate together with meaningful feature parity. So these 8 criteria became the lens for everything what we observed over the next 6 years. And now let's talk about what we found. So here's the corpus we're working from. We have 32 time-stamped sessions Over 30 hours of recorded conversations, well over 30 hours. Our outings often went overtime. And I do want to mention that these are all we had because we didn't actually start live streaming these outings right away. It was only after maybe a year that we started capturing the video and audio. So we've actually clocked a lot more time in these worlds than just the 32 transcripts that we have for this. Platforms that we visited, and usually multiple times, include Altspace VR, Chill Out VR, Decentraland, Engage, Equimuck, Frame, Hyperworld, Minimizens, Wayne Test, Rec Room, Roblox, Samsar, Sciencebase, Simulspace, Spatial, VR Chat, and Verbella, and there's probably more. So not every session we've ever held was recorded, but the recordings we have were all auto-captioned by YouTube and everything transcribed is timestamped. By the way, I want to mention too that none of these recordings are available publicly. We live stream them simply to capture the audio and visuals for later analysis when and if we had the tools that would help us do so. Second Life is our baseline to all of this. It's the platform that we've always come back to. It's exactly what we're implicitly comparing everything against, not because it's perfect, it's not, but because it is a platform that has served educators the longest and most consistently, and it's still a home base. Most of our VR Exploder colleagues have a lot of experience with Second Life, but not all of them. But here's where the adventures really begin. Because having 32 transcripts and 30 plus hours of data is one thing, but actually reading and synthesizing all that is another thing entirely. And that's where AI really made sense to utilize. We don't have graduate students to watch and manually code how many times people's systems crash because the platform was glitchy. But we know all these conversations between us educators who are experiencing using virtual spaces and teaching that we knew it was a gold mine and that AI could help us make sense of it. So plan seems simple enough. We had a large corpus. We had a consistent structure across all the sessions. We had the same props that we'd used throughout. But we could use generative AI as a synthesis partner to identify platforms or patterns, across 32 transcripts that we wouldn't be able to manually do this ourselves. It would just be ridiculously labor intensive. So this use of AI is exactly what Maul means by seeing it as a co-intelligence. It sounded so simple, you guys. The AI was not going to write our conclusions for us, but we hoped it would help us see patterns at scale that would have taken us weeks to work through manually. And Ray and I knew that we had attended all of these outings, and we were longer even in many of the quotes, and sometimes even who said what. We felt confident in our own anecdotal takeaways, but this would be the first time that we would have an outside intelligence describe for us what it was seeing in the data. So that's an exciting prospect. So we started with the Gemini AI model because I was under the impression it could view videos, and that was not a feature in our GPT accounts. When you give Gemini a YouTube video link, it returns a comprehensive description that my early testing fooled me into thinking it was seeing and hearing the video. I got my own paid pro account for Gemini, and while I wasn't entirely being naive, I was hoping it could just give me a list of all our links and then just get something useful. Actually, nothing is that simple. We went out to develop some training and query prompts specifically designed to constrain the analysis to what was actually in the transcripts, verbatim evidence only, no inference beyond what was explicitly stated. But before we could build those guardrails in properly, we needed to discover for ourselves exactly why they were so necessary. This prompt structure we eventually arrived at, and we want to show it to you before we show you the failure attempts that made it necessary, because the sequence matters. Framework first. That's the reason we needed it. The key rules were analyze only this single session. Do not compare it to other sessions. Use only the provided timestamp transcript lines as evidence. Do not refer or assume anything not explicitly stated. Every claim must be supported by verbatim quotes within hour, minute, and second time codes. Use the required output template. The output template required a session header with metadata, an explicit data integrity report, a summary, thematic quotes. The quotes had to be with time codes and evidence index and references. And critically, if there was no transcript provided, the manual was required to stop. No transcript, no analysis. This prompt did not come from some best practices guide. It came about because we got burned by what we found when we first started feeding data to these models. And I'll be honest, it would have been hard to catch. We were fortunate in that we know our data pretty well because we were there. But let's take a minute to look at a couple hallucination examples that we experienced. Here's the first example. We gave Gemini a YouTube link to one of our VR Explorer session recordings, and actually, I think I grabbed the video at random. It just so happened that particular video, the audio file was corrupt. And you could hear was static and some periodic beeps. I had thought that Gemini could watch the video and describe what it was seeing. So there was a whole session of action on the screen, but there was no actual voice or conversation. Gemini produced a full, very confident sounding detailed analysis, complete with quotes and with timestamps, complete with participant dialogue. Specific things were said at specific times in a session that didn't have audio. How was this possible? First, it's not enough to get reliable information from our AI models. All of us are trying to learn how they work under the hood, understand the gaps in the reasoning that enable us to speak to our machines to build the guardrails we need. The only way I know how to learn how to do this is by this kind of tinkering. In my work, I want to be very transparent in my fumbling around because it's part of my job as an instructional designer to model this sort of fearlessness. Imposter syndrome is incompatible with a world that is rapidly changing. We have to model for others that it's okay to not know everything and to not have all the answers. I'm trying to model for others my real process so they feel empowered. And we learn by making mistakes and then by diagnosing them. And so now more than ever, I think this fearlessness and this transparency is critical to model for each other, for our students, because there's going to be a whole lot more uncertainty to come. So when we asked this model, when the video it was seeing these things, that's when we learned that it was not able to analyze video files at all. It was inferring information from the title, from information in the description box, and anything in a caption file, but there was no caption file. And when we pointed that out, the model admitted, and we're quoting directly here, the quotes I provided are synthesized examples of what participants typically say during these sessions, rather than word for word playback. So let's sit with that for a minute. I asked it if I could give it a video link, if it could provide me a summary of what was happening in the video. It confirmed that. It gave me a great summary on some of them. So it's my bad in that I'd assumed it was able to ingest an MP3 video file. I don't know what these models are capable of, right? They sometimes do seem incredible enough to do exactly that. In fact, I fully expect AI will soon be able to watch videos without audio and be able to describe what it sees. Don't you kind of think that's kind of? But the model looked at a video full of static, decided it knew what this video was supposed to be, drew on its training data about what the VR Explorer sessions typically sound like, and constructed the authoritative looking analysis. So it was very confident, very well formatted hallucination. It certainly sounded about right. But this was the start of our suspicion of thinking to how to model and interpret multiple video links in a single chat thread. That was not going to work at all. So training a particular chatbot on too much information about the purpose of the VR experience was problematic. We don't want to tell it too much at all. So our second example is perhaps even more instructive. We gave the model a single YouTube URL. The video was clearly labeled in the title, the metadata, and everything. VR Explorers, Sansar, Part 1, May 2021. The model returned a full analysis of a completely different platform frame with the date of March 22nd, 2024. It was a complete fabrication with quotes and participant behavior, fabricated session data, the whole thing. So it was presented in the output format we had requested and beautifully organized with headers and timestamps and the structures that looked entirely legitimate. When confronted, the model apologized and that it had hallucinated the metadata and all the content. It had no access to the video. It could not watch the video, but it produced a full formatted, authorities-looking report anyway. So here's the lesson we took from this, and it goes directly to the heart of our work as information professionals. It is essential to understand how to create restrictions and guardrails in order to get anything reliable. And this is not as easy as it sounds. A report can look like it follows all the right conventions. It can still be giving output that is entirely from inference and invention, but even citing things that actually happen in other platforms. That's why it fooled us. The model has no idea, what was in that video. It produced something that looked like it did because it was filling in the gaps with inferences from our other video links. If we had not known our own data because we were at all these outings, we might not have ever caught this. The insights about Frame, they were not bad, but the fact is we gave it a video about Sansar. So it could be in the early part of the script we were talking about Frame VR. I'm not sure, but the Gemini gem we're using failed us this second time, and we had to go back to the drawing board. So needless to say, we were discouraged, but we resolved ourselves to keep working to redesign our prompting and to test outputs using multiple AI models. We also decided just to abandon the use of Gemini for the time being. We decided to focus on auditing our models as part of the presentation here. So Marie and I both started working together to compare notes in our testing. We used AI to help us redesign our approach and our prompt to train our model. The redesigned prompt required verbatim quotes only, nothing paraphrased, nothing synthesized without attribution, Allen minute, second time codes on every claim. And we made it get us an explicit data integrity report at the top of each analysis. We wanted to make sure that we knew what the model actually had access to and what the condition of the transcript was. Were there gaps in the transcript? Were there unclear sections? So we wanted to be explicit in where every insight was coming from. If there was no transcript, the model needed to stop and say that the session was not analyzable. It was not allowed to guess, infer, or try to be helpful in filling in gaps. That shift from trust to audit is what we do as information professionals and as educators. We can't ignore the fact that it's yet more layers of information, though, to manage and to parse. Provenance and source verification used to be easier in the old days. The world now, though, is so much more complex. The amount of information we need to sift through is increasing exponentially, and we're going to need to use AI to help us in this task. But at the same time, it is intimidating with the scale of all of this. AI as a co-intelligence does work, but only when you are really diligent and double and triple checking the work. This is where I start to have second thoughts that all this AI is making our lives easier and more productive. So we decided to double down on our efforts and we ran all 32 transcripts through both Claude and through GPT separately using the same strict prompt and query verbiage. Marie was working with Claude and I was working with GPT, and they started to find things. And here's where I'll let Marie take over to talk about the key findings.
Okay, great. Thank you, Bethany. So there were 8 key findings that both our AI models uncovered. So let's talk about them one at a time. First, the time to join matters enormously in an educational context. And it matters in ways that are easy to underestimate until you're standing in front of a class or a group of educators who are unfamiliar with that particular platform and watching it happen. Ribblocks is, as just one example, required 3 separate applications just to arrive in the space. Rec Room took us through reinstall loops. Mindtest hit registration timeouts. In every one of these cases, the friction did not just slow people down. It sometimes consumed up to the first half hour of our session out of an hour. In a class, that time is at the beginning is when most students are the most alert and ready to engage. And when that happens, the instructor does not get to teach. The instructor just becomes a tech support and traffic controller and emotional support for the students who cannot figure out why their avatar will not load. The practical implications we draw from this is onboarding should be treated as a curriculum infrastructure, not as a first day hurdle you hope students can clear on their own. It should have its own one-page guide. It should have a pre-class tech check world. It should have a designated role, someone who is going to stay at the door and help people get in while the instructor starts the session. If you would not walk into a classroom and assume the projector would be working, do not assume that your students can onboard themselves into a new VR platform without some kind of support. For all the complaints about the learning curve of SL, we can say with a lot of confidence that nothing is easy. Finding two, having voice is not the same as having a voice that works for teaching. This came up repeatedly across platforms. In all of our outings, we just used Discord because that was the easiest. Discord became what our AI analysis describes as shadow infrastructure. It's the communication layer that was not built into the platform, but that people needed in order to actually function. The problem with shadow infrastructure is that it adds cognitive load. It creates a second window to manage, and it means that the platform that you are on is only partially doing its job. We used Discord because it was consistently the easiest way for us to all hear each other no matter where we were. But we heard this directly in our sessions. In a Meta Horizons world visit, a participant said, and we are quoting directly here, chat is an essential feature for accessibility. Hard of hearing or deaf. It's a problem. That is not a feature request. That's an accessibility requirement. Text chat is not a fallback for when voice breaks. Text chat is accessibility infrastructure. It supports deaf and hard of hearing users. It supports quieter participation styles. It supports link sharing. It supports the student who does not want to speak aloud but has something to contribute. But there are problems with text in many of these platforms. In some, it just disappears really quickly, not like we're used to in SL. And the privacy dimension matters too. In Engage VR, the default of the microphone being on was flagged in our sessions as a genuine privacy risk. Students should not have to know how to turn their mic off. The default should protect them. Voice presence is also not the same thing as voice reliability. A platform can have voice and still not be ready for the classroom. Finding three is perhaps the most important reframing in this entire presentation. Access is pedagogy. The question is not whether a platform supports VR. The question is whether desktop users, browser users, mobile users, and headsets users can all participate meaningfully together with comparable features. We observed this failing repeatedly. In a spatial session, headset users could not find the chat interface. Desktop users described their experience as 10 times better than what the headset users were getting in one session. A participant had to remove their headset mid-session because of nausea and display flicker. And then there is the practical reality for educational institutions. Very few instructors can require students to own a VR headset. Even institutions that loan equipment cannot guarantee that every student will have access to a headset for every class session or for an entire semester. For education, VR must be optional. Desktop parity is not a nice feature. Desktop parity is a feasibility requirement. If a platform cannot give desktop users a meaningful equivalent experience to a headset user, it cannot sustain a semester-long course. Of course, this observation begs the question, if an environment provides just as good an experience on desktop without a VR headset, Why not just use the desktop VR environment for education? When we say access is pedagogy, we mean it literally. Designing for access is designing for learning. The moment you exclude a subset of your students from full participation, you have made a pedagogical choice, whether you intended to or not. Finding four, you, if you cannot keep your class together, you cannot teach. This kind of sounds obvious, but the number of platforms where we watched groups fragment because of inadequate teleporting or wayfinding was striking. Their group navigation is not a minor inconvenience. It changes the character of what you can do in a session entirely. In a Roblox visit, we noted when you can't fly, it takes forever to get somewhere. In Decentraland, you can run for an eternity, and the maps were described as low information, meaning they did not actually help you navigate it. You were just running. When an instructor cannot reliably move a group from one place to another, the options are to stay in one place, to simplify the lesson until it fits a single location, or to spend so much session time herding cats that there is nothing left for teaching. The best educational implementations we saw had a specific set of tools: an instructor summon all function, clearly marked spawn points, and visible wayfinding. These are not fancy features. They are the virtual equivalent of saying, "Everyone follow me," and having students actually be able to see and follow you. Group flow affects learning flow. If your students are scattered across the environment trying to figure out how to get somewhere, they're not learning, they're navigating. So now we want to shift from what platforms do wrong to what they do right, or at least what they do right when they are at their best. Finding five. The strongest educational signal we saw across all 32 sessions was learner creation. Not learner consumption, not learner observation, learner creation. The most powerful moments in our data were moments where learners were building something, remixing something, co-designing something, shaping the environment itself. Not touring an impressive space, not watching a presentation. Building. In a VR chat session in an educational world, we observed an instructor clicking a board in global mode, meaning that when the instructor selected something, everyone in the room saw the same selection simultaneously. That's not a visual trick. That's a shared state interaction, and it is exactly what education looks like at its best. Everyone in the room orientated towards the same thing in the same way, by design. In Science Space, participants were flying, interacting with objects, and working through quest-style content. The engagement was qualitatively different from sessions where people were standing in a beautiful space doing nothing interactive. Platforms that look visually impressive but limited what learners could do with the environment consistently underperformed on the educational usefulness dimension. Passive immersion is not pedagogy. Presence in a beautiful space is not the same as learning in an active one. Finding six qualifies finding five in an important way. Because when we say learner creation is powerful, we need to be honest about how many platforms actually support it in a way that educators need. There is a difference between a platform that says it supports creation and a platform that lets learners build things in the moment, in the room, without a technical pipeline. Roblox is perhaps the clearest example. Roblox supports creation, but as one of our participants put it, you build it in Creator and then publish it. There's no building on the fly. Students cannot pick up a block and put it somewhere during class. The creation happens outside the platform and gets imported in. That's a fundamentally different affordance than what Second Life educators rely on. VR chat requires a Unity pipeline for world creation. Equimake ran into object limits and confusing import errors. Contributor settings were barriers in multiple flat platforms, meaning that even when building was theoretically possible, the permission structures made it inaccessible in practice. No platform emerged in our data as a complete successor to Second Life in World live creation model. We want to say that clearly. Creative affordances are often narrower than they appear from the outside. What looks like a creative platform may have a very high barrier between what you can do as a visitor and what you can do as a builder. Finding seven is the one that perhaps most directly affects whether any of this is adoptable at scale. Reliability and safety are not optional features, they are institutional requirements. Crashes, lag, sync, feed failures, and moderation surprises reoccurred across our sessions, not as rare events, but as expected hazards. And in an educational context, these are not just annoying, they are disqualifying. Some examples from our data include the fact that I was banned from Roblox for a day for uploading a slide deck that triggered a content filter. Not because I did anything wrong, because the automated system flagged my educational content, and in a spatial VR session, a default avatar accessory was interpreted as a weapon, resulting in the entire space being shut down. This was at my institution, and it had a really big impact on me and my students. In Somnium Space session, participants expressed direct, explicit doubts about whether the platform could still be running by the following semester. That kind of platform instability makes it genuinely difficult to commit to a course design built around it. Institutions need predictability. They need privacy defaults that protect students. They need safety tools that let instructors manage their class environments without needing to be platform administrators. And they need reasonable confidence that the platform will still be around for the duration of the semester. Features of without reliability are not enough. A platform can do everything on its own criteria list and still be unusable if it crashes in a week or three, or bans you for showing specific PowerPoint. Finding it closes out the section and builds directly on what we said about learner creation. Presentation tools matter. We're not dismissing them. Browser-based platforms like Spatial and Frame perform reasonably well for guided tours, exhibits, and structured presentations. Frame in particular worked for certain kinds of classroom showcase experiences. But the presentation is a ceiling, not a floor. It is the minimum educational function, not the distinguishing one. The best educational experiences we observed combined presentation with something more, with instructor guidance that moved the group through a space, with learner agency that let participants interact with what was being presented, with shared state interaction, and what the instructor was doing was visible and meaningful to everyone at the same time. Frame hit a one browser per frame limit. Somnium Space media interactions were local, not shared, meaning that what one person saw was not what everyone saw, which fundamentally limits classroom instruction. And the VR chat example we mentioned a moment ago, the instructor clicking a board in a global mode is exactly what excellent presentation infrastructure looks like. Not a slide projected on a wall, a live, shared, interactive moment that everyone is experiencing together. Educational value comes from interaction, not display alone. If your platform can show things but not do things, it's a very expensive projector. Okay, so after the hallucination discoveries, after we built our guardrail prompt structure, we ran all 32 transcripts through both Claude and GPT independently. The same prompt, the same time-stamped text files, same required output template. Then we use GPT to compare the two sets of outputs and identify convergence and divergence. We want to be very clear about something before we go further. We were not drawing hard conclusions from this comparison. The models themselves are moving targets. They are updated, fine-tuned, and changed without warning. We approach this loosely as an exploratory exercise, not as a definitive study. And even with that caveat, the comparison was genuinely useful because both models, running independently on the same data, largely converged on the same major themes and patterns. That convergence told us something important about the patterns we were seeing, that they were not artifacts of a single model's framing. They were robust enough to survive two different analytical approaches. This delighted us because it also confirmed that what the two of us felt like were our anecdotal takeaways from having been on all these outings. It was nice to see it confirmed by an outsider, not telling us what we wanted to hear, but in listening to all the conversations and putting these puzzle pieces together into the same essential picture. That said, they did not agree on everything, and the ways they disagreed were really interesting. That our GPT leaned towards operational and infrastructural analysis. When it organized the findings, it organized them around classroom constraints. Sorry. Organized and what were the barriers? What were the failure modes? It was more rubric-oriented, more systematic. GPT gave more explicit attention to what we called the shadow infrastructure, the Discord dependency pattern, and framed that as an indicator of native communication failure. Like we mentioned, however, that reliance on Discord was our choice, but it was made for the reason that the models still inferred unreliable or inconsistent communication in world. Claude leaned toward thematic and interpretive analysis. It drew broader conceptual arguments about learner agency and the relationship between creation and learning. It was more discursive, more willing to synthesize across sessions into a larger interpretive claim. Claude was also more willing to name specific platforms, most notably roadblocks, as the closest functional successor to certain Second Life affordances. That insight delighted us again because Bethany and I independently had concluded this a while back, and we were actively working on that platform. Neither of these approaches was wrong. They were genuinely different angles on the same data. One leaned towards systems and structure, the other leaned towards conceptual synthesis and educational meaning. And for the exploratory qualitative work, which is what this is, having two angles on the same corpus is more useful than having one. It's not a competition, it's a triangulation. So here's where both models landed independently on the same conclusions. These are the findings we are most confident in. No single platform fully replaces Second Life. That is the headline finding. 6 years of data, 2 independent AI analysis, and our own lived experience all point to the same place. The successor platform does not yet exist. What exists is a landscape of partial successors, each of which captures some of what Second Life offers, but none of which captures all of it. Roblox is currently the top contender, but who knows what the future holds. Both models identified onboarding friction as a serious educational barrier. Both identified Discord dependency as a signal that native communication is not classroom ready. Both flagged text chat as an essential infrastructure, not a fallback. It is not a convenience, but a requirement. Both models confirm that cross-device partially matters enormously, that learner agency and co-creation are the central educational affordances in these environments, and that platforms tend to divide up a Second Life's strengths rather than combining them. The partial successors that emerged most clearly were roadblocks, science space, and spatial/frame, but each for different reasons in different contexts with different limitations. None of them is the platform you could use for everything that's SL Educator currently do. So what we actually take away from the fact that the two different models run on the same data produce largely convergent findings. We take it as a meaningful signal, not proof, but not certainty, but reinforcement. When the two independently run analysis point in the same direction, that tells us the patterns are not a product of one model's particular interpretive tendencies. They're visible enough to survive two different lenses. When the models diverge, they organize the same things differently or emphasize different aspects of the same evidence. That divergence is also informative. It tells us which aspects of the data are more interpretation dependent, which conclusions require more human judgment to sort it out. And neither model replaced our judgment. Both helped us see the corpus more clearly. That is the co-intelligent model at work, not the replacement. Thinking partnership that still requires a human at the wheel. This matters beyond this particular study. AI is becoming more a part of how we design courses, build curricula, summarize research, prototype ideas, and reflect on our own practice. This is not going to go away, but it requires transparency about what the AI was given, what it was asked to do, and how you verified what it produced. Confidence is not accuracy, formatting is not provenance, and the receipts still matter. Okay, so the 2020 question, were we right? Mostly yes. The 8 criteria we identified in 2020 held up. All 8 of them were confirmed by lived experience across 32 sessions. They are still the right things to look at when evaluating a social VR platform for educational use. But we missed 2 things, and we want to name them explicitly. The first addition is text chat and link sharing. This came up so repeatedly, so often in our data in so many different contexts that it cannot be treated as a sub-feature of voice. It is a standalone criterion. It is accessibility infrastructure. It is how people share resources, participate in alternative modes, and communicate when voice fails. It needs its own line on the checklist. The second addition is co-presence reliability. This is the question. Can you actually keep a class together? Can you all your students be in the same instance with the same features, experience the same session? Instance fragmentation, where different participants end up in different copies of the same space, was a primary failure mode in our data that the original 8 criteria did not specifically address. The 2020 framework was good. The 2026 revision makes it a lot stronger. And the process of checking our own earlier work against 6 years of evidence is, we would argue, exactly what good information practice looks like. So here then is the practical takeaway. For anyone in this room who is evaluating a social VR platform for educational use, the 10 criteria, 8 original and 2 new ones. Voice, real-time presentations, onboarding, griefer handling, multimedia and recording, desktop VR access, teleporting and regroup, cross-platform participation, and then adding the 2 new solutions, which is text chat and link sharing, as well as co-presence reliability. So maybe we should print and laminate this checklist, because this is what we would recommend you take with you when you visit a new platform. Okay, so we want to close this section with something a little bigger than a checklist. We called this talk Snarky and Sass to go nuts because it is what it has felt like. It's frantic and overwhelming. There are more platforms than we can fully understand. Features are changing constantly and more AI capabilities than we can fully track. But there is what we actually believe after 6 years of doing this work. We are building something, not completing it. Each session we ran, each platform we explored, each analysis we ran and then audited and then ran again, all of it is yet another acorn. Some of them are good. Some of them are the ones we buried and forgot about. Some of them turned out to be rocks. But the tree grows from what you save and tend, not from what you dismiss because it's complicated. The tree does not grow in a straight line either. It is branching, messy, and sometimes growing in directions you didn't plan for. Then it may need pruning. Our job as information professionals, and we think as educators more broadly, is not to have all the answers. It's to have a model how to ask better questions, how to verify sources, how to preserve provenance, how to keep building even when the forest is loud and the acorns are falling fast. AI is a powerful tool in that process, a genuinely useful tool, but we have, as we have demonstrated today, a sometimes unreliable one that will confidently invent content from static or your other related context if you let it. The framing we keep coming back to is Moloch's co-intelligence, not replacement, a partnership, one that requires humans at the wheel, human judgment on the findings, and human accountability for what gets shared as true. So this is what we want you to take with you. Across 6 years of VR Exploder outings, the most consistent finding was the educational value in virtual environments depends less on immersion alone and more on access, communication and co-presence, learner agency, and institutional practicality. Please, IM us, friend us if you want more information, because I see we're out of time. Thanks.